Dear students, hope you are all well. So today we will begin with the chapter in geography. The name of the chapter is temperature. In the previous chapter, we looked at the meaning of weather and climate and also the different elements of weather. Now let us see the learning objectives of this lesson. We will be learning about meaning of temperature, distribution of temperature, range of temperature and the greenhouse gases along with the greenhouse effect. Let's move forward. Now, you can see three figures over here, right? The atmospheric conditions of a place at a given time keeps changing. As these conditions are short-lived is what we called weather. That is the first picture. For example, it was cold in the morning. It rained suddenly in the afternoon. Then cool breeze was blowing in the evening. That is the weather changes. It is for a short period of time. Then the second picture is climate. The average weather condition of a place observed over a long period of time is the climate of that region. Climate is generally expressed as cool or dry, hot or humid, or hot and dry. So, how is climate expressed? Cool or dry, hot and humid, or hot and dry. The weather changes quite often, right? As I told you, weather changes quite often. It is for a short period of time due to changes in temperature, winds, and humidity. A sum total of all these elements define weather. Now, other elements of weather is the third picture, temperature. The earth's surface gets heated from the sun. The air close to the surface starts becoming hot, and later, one by one, different layers of air at higher level receive heat. Therefore, as we move upward from the sea level, the temperature of the air decreases. That means as we go higher towards the sky, the temperature decreases. The temperature also goes on decreasing from the equator towards both the poles. If you go towards both the poles, that is the south and the north pole, the temperature decreases over there. Now let us see what is temperature. So, temperature is defined as a degree of hotness or coldness measured on a definite scale. Let me give you an example. When you get fever, you visit a doctor, right? And the doctor tests your body temperature using a thermometer, right? In the same way, everybody and every place has its own temperature. For example, you take the current temperature of Mumbai city is 29 degree Celsius. That's just an example. Now children, let us do an activity. Let us find out how the sun rays affects the atmospheric temperature of the earth, right? For this activity, you will need a torch and you will need two large white papers to check how the rays heats up on the earth surface. Now, take a torch light and keep it still at one place. Then take two large paper sheets large enough to accommodate it and its entire beam. Beam means from where the light is passing from the torch. That's called beam, the yellow portion. Okay. Paste the papers on two flat boards. Hold the board perpendicular to the beam. Draw the outline of the area lit up by the beam and name that paper A. So the first paper you name paper A. And from where the light, the beam is coming, you will make an outline. Okay. Now use the other paper. Hold it in such a way that it makes an angle of 120 degrees. That means the second paper, you have to hold it a bit slanting. Then draw the outline of the area occupied by the beam and name that paper B. Now let us observe the differences between paper A and paper B. On which paper does the beam occupy a larger area? Now from these two papers, on which paper does the beam occupy a larger area? As you can see, the paper B occupies larger area of the beam. Right? Can you see the paper B is occupying large area? Now the next question is, on which paper is the area smaller? It is smaller on paper A. Now change the angle between the beam of the light and the paper. Now you have to change the angle. Observe the changes that occupy in the area by the beam of the light. We all observed the differences, children, before, right? Now what is the relation between the angle of the paper and the area occupied by the beam of the angle is paper A is 90 degrees, right? You can see over there, paper A is 90 degrees. Hence, the area occupied by the beam is smaller. Paper A is 90 degrees, so the beam occupied by paper A is smaller. Whereas in paper B, the angle is 120 degrees and it's slanted, right? It is slanting. Hence, the area occupied by the beam is much more larger. Let's move forward. Now, the sun rays coming to the earth travel in a straight line. However, as the earth is spherical in shape, as we know, it is round in shape. These rays are not perpendicular to all parts of the earth's surface. That means the earth doesn't get rays from the sun straight at some places. At some places it's straight, some places it's slanting. So in some parts they are perpendicular, whereas in other parts they are slanting. The part where the rays occupy lesser area is receive bright sunshine and greater heat. As you can see in the third figure, the A, where it's written A, that the sun from the earth is getting direct sun, but on C it is slanting. So A will get more heat and C will get less heat. Okay, hence the surface there gets heated more and the area becomes hotter. Then the slant rays occupy a larger area. Now C is occupying a bit more area. In these areas the sunlight appears little bright. Okay, and there less heat is there. Okay, hence the surface there of that place gets heated and the air too is less hot. That means you can see in the third figure, the C is slanting ray, so there the heat is less. Let's move forward. Now children, as you have seen that the rays from the sun fall on the earth are straight and parallel to each other. We also know that the shape of the earth is round. We all know now the shape of the earth is round and it has a curved surface. That is why they occupy a larger or smaller area. As I told you just now in that figure, the last figure, where the sun is, where the earth is getting direct sun rays, you'll get more heat. But where it is slanting, you'll get less heat. This leads to unequal distribution of heat received by the sun. That means all the parts of the earth does not get, everywhere you will not get the equal heat. Some places it's a bit less heat you will get. Okay. So this leads to unequal distribution of the heat received from the sun, resulting in decrease in the temperature from the equator to the north and south poles. Now, based on the distribution of temperature, the earth can be divided into three zones. The earth is divided into three zones. Let us see that. First is torrid zone, torrid or tropical zone. Second is temperate zone, and the third is frigid zone. Now, torrid zone you will mostly find where the equator is. So torrid zone will be a little bit hotter. Temperate zone, that's the second zone. Now temperate zone will be above torrid zone. Okay, so there it will be moderate. That means the less will heat will be a little medium. And then the last is frigid or polar zone. Now in this zone, the temperature will be very less. Okay, and it will be very cold in these regions. Okay, polar zones. Let's move forward. Temperature differs from one part of the world to the other. The earth can generally be divided into three broad temperature zones. That is the torrid zone, the temperate zone, and the frigid zone. So how you will remember is the torrid zone. The torrid zone is where you get most of the heat. Why? Because it's in between the equator and it's between the earth, right? Between the earth's surface, and there the earth gets direct heat of the sun. Then after that is the temperate zone. Temperate zone will get heat but not that much. So it will be moderate or medium. And the third is polar zone, that is on top, right? North and south poles. So there the temperature will be cool. Okay. Let's see now all these three in detail. The first is tropical zone or tropical region. The temperature remains high. Sun is directly overhead at least once during the year. The tropics are regions of the earth that lie roughly in the middle of the globe. As I told you, it lies in the middle of the globe. That is where the equator is. It includes the equator, parts of North America. So which all places come under tropical zone? They are North America, South America, Africa, Asia and Australia. So all these places are under tropical zone. The tropics are warm all year. That means this area or this region gets heat, lots of heat, averaging to 25 to 28 degree Celsius. Okay, so the temperature over there is 25 to 28 and it increases also. The next is the temperate zones. Now the temperate zones are the mid-latitudinal zones. Why it's called mid-latitudinal? Because it is in between. It is in the middle. So it's called as mid-latitudinal zones. There the temperature is moderate. Means it's not that very hot, not very cold. It's medium. Okay. There the temperature is moderate. There are two temperate areas, that is north and south. The temperate zone mainly lies between the tropics and the polar region. As you can understand, it's in between, right? It's in between tropic and polar regions. The temperate zone includes the continental USA. Now, which places come under temperate zone? They are continental USA, most of Canada and Europe, Central Asia, Southern South America and Southern Australia. It generally has 4 different seasons. Now these all places have generally 4 seasons. They are spring, summer, autumn and winter. Now let us look at the last zone, that is the frigid zone. So the two frigid zones or polar region experiences the midnight sun and the polar night for the part of the year. The frigid zone in the northern hemisphere. Now why is it said two frigid zone? Because it is in the northern and the southern hemisphere, north and south. So it is called as two frigid zone. The frigid zone in the northern hemisphere lies between Arctic Circle and the North Pole, and in the southern hemisphere between the Antarctic Circle and the South Pole. Now as you know, Arctic and Antarctic, it's a cold place. In summer, Now just see over here, in summer the temperature varies from 3 degrees to 12 degrees. Now in our place summer means it's very hot, but look over here, the temperature in summer in the polar region or in the frigid zone, it is 3 degrees to 12 degrees, means you can see that it is very cold or very low the temperature is. This is the coldest area on the surface of the earth and covered with snow throughout the year. So these areas you will see snow covered throughout the year. Let's move forward. Now next is the factors influencing the distribution of temperature. Now the main factor is known as the parallels of latitudes. Now you all have heard about this in your first and second chapter in geography. Parallels of latitudes. Latitudes are the sleeping lines. You can see in this figure the sleeping line, the equator, Tropic of Cancer and Tropic of Capricorn. They are latitudes and that's why they are called as parallels of latitude, because they are all parallel to each other. The circles created at some angular distance from the center of the earth and are parallel to each other. As you can see, all these lines, Tropic of Cancer, equator, Tropic of Capricorn, they are all parallel to each other. The values of parallels are angular measures expressed in degrees. As you can see in the figure, it's expressed in degrees. The next factor is the nearness to the sea. Now, the next factor for the distribution of temperature is nearness to the sea, which means the distance of the sea close to the land. That means where you find beaches or seashore, right? And then last factor and then third factor is continentality. Continentality which means the difference between the temperature occur between land and the sea. The other factors influencing the distribution of temperature are height above the main sea level. Okay, the height above the main sea level, that is the features of the surface. Then the nature of the landscape, also known as the physical setup, as well as one major factor affecting the distribution of temperature of earth is the distribution of the land and oceans. Since there is more land in the northern hemisphere and more water in the southern hemisphere. So you will find more land in the northern hemisphere and lots of water in the southern hemisphere. There is a big difference between specific heat of land and water. The loss of heat from the continents is bigger than the ocean. The continents get heated faster and gets cooled faster comparison to the ocean. This is the reason that the temperature of the oceans are moderate while that of the continents is extreme. That means where you will find sea or coastal areas, there the temperature will be a bit less, but where you will find continents or continentality areas where there is land, the temperature will be a little higher. Next children, let's do an activity. This activity will help us understand the difference in the heating and cooling of land and water. For this activity, we will require 2 pots of the same size and to fill them with water equally. Now take 2 pots of the same size and fill them with water equally. At sunrise, that means when the sun rises, keep one of the pot inside the house and the other one outside. See that it remains in the sun all the time. That means which pot you're keeping outside the house, look that it will be in the sun all the time. In the afternoon, walk barefoot on the floor inside the house. First you have to walk inside the house and feel the temperature of the floor. Same way you have to feel the temperature of water in the pot kept inside your house. The same way you have to perform the same activity outside the house and get the feel of the temperature of the land and the water kept in the sun. Now after doing this, write your observations about the temperature of land and water. So you have to write your observations. The observations are as follows. We understand that the land cools earlier than the water. Okay, so the land cools down earlier than the water. land gets heated faster and also cools down faster. So land gets heated also faster and also cools down faster. But the other way round, the next figure, water, the water kept outside in the sun is still warm. Okay, is still warm. Water gets heated slowly and also cools down in a slow manner. Okay, let's move forward. Now you must have realized that the land cools down earlier than the water. And also the water kept outside in the sun is still warm. The air over the water gets heated slowly and also loses the heat in a slow manner. So in the coastal areas as compared to the continental areas, the temperature of air is lower during the day but warmer in the night. That means the temperature in the coastal area is lower during the day and gets warmer in the night. Contrary to this, the temperature of the air in the continental areas is higher during daytime. That means where there is land, where there is greenery, there it is higher during the daytime and lower at night. The temperature gets lower at night. Now, what are coastal areas? Coastal areas are commonly defined as the area in between land and sea, which includes large lakes as well. So, in coastal areas, you will find lakes, oceans, okay? And continental areas are basically large areas of land which has no sea or lake surrounded by it, near it. Okay, you will not find any lake or any water body surrounded in the continental area. Let's move forward. This is a water cycle. Now, the water cycle has no starting point, right? A water cycle from where it starts, it does not have a starting point. But we will begin in the ocean. So, we will begin from the oceans. Since that is where most of the water exists. You will find most of the water in the ocean. So the sun, which drives the water cycle, heats water in the oceans. Some of it evaporates as vapor into the air. Can you see from the ocean there are some arrows moving upwards? So that is the water vapor. Okay, this vapor rises into the air where cooler temperature causes it to condense. Now where you will find cooler temperature? Now these arrows are moving upwards. So as you go higher, the temperature gets cooler. Okay, cause it to condense into clouds. As you can see in the figure, it is condensing into clouds or it forms into clouds. Now we know in the coastal areas, because of the heating of water, water vapor gets mixed in the air. This water vapor holds the heat in the air. As a result, the air in the coastal area remains moist and warm. So when will you find the air in the coastal areas warm? In the night. Conditions in the continental areas are quite the opposite, right? It's always opposite. As water vapor is absent, the air remains dry. This leads to swap differences in the day and night temperatures, as we seen in the previous slide. The differences in the maximum and minimum temperature of a day is called range of temperature. Let's move forward. Now, as you understood that the difference in the day and night temperature is less in the coastal areas and more in the continental areas, which is also known as the range of temperature. One example of it is Mumbai. Temperature are even, but at Nagpur they vary a lot. As Mumbai is a city next to the sea, hence it falls under a coastal area. And as you know that Nagpur is a city not close to the sea, hence it falls under a continental area. So you will call Mumbai as a coastal area and Nagpur as a continental area. Now, in the coastal regions of Konkan, the range of temperature is less. But in Vidarbha, Konkan is a coastal area. So, there the temperature will be less. But in Vidarbha, the range of temperature is found to be higher. Therefore, coastal areas have an equable climate, whereas in continental areas, the climate is extreme. So, how to understand about this? The coastal areas, temperature gets lower, and continental areas, the temperature is higher. For example, the climate of Mumbai is equable, whereas in continental locations like Nagpur, it is extreme. So the difference in the mean temperatures of summer and winter is called the annual range of temperature. Okay. Now the next, let us learn about the greenhouse effect. Greenhouse effect is a natural process that warms the Earth's surface when the sun's energy reaches the Earth's atmosphere. Some of it is reflected back to the space, and the rest is absorbed and re-radiated by the greenhouse gases. Now, what are some of the greenhouse gases? Include water vapor, carbon dioxide, methane, nitrous oxide, ozone, etc. Solar radiations reaches the Earth's atmosphere. Some of this is reflected back to space. Now, as you can see in this image, the rest of the sun's energy is absorbed by the land, right? That is absorbed by the earth. And the oceans heating the earth, heat radiates from the earth towards space. Some of this heat is trapped by the greenhouse gases in the atmosphere, keeping the earth warm enough to sustain life. Human activities, that means what we do. Human activities such as burning fossil fuels, agriculture, and land clearing are increasing the amount of greenhouse gases released into the atmosphere. This is trapping extra heat and causing the Earth's temperature to rise. Now, as we came to know that some gases in the atmosphere like carbon dioxide, water vapor can hold the heat within themselves for a long period of time. Due to these gases, the temperature of the air in the atmosphere increases. The temperature increases. This increases propagation of these gases in the atmosphere leads to climate change. Then the climate gets changed. Climate scientists believe that this is the reason for the increasing temperature of the earth. That is, the change in the climate is global. Hence, it is known as global warming. This is called global rise in temperature. The gases due to which temperature increases are called as greenhouse gases. Let's move forward. Now, the next is the geographical museum or geographical information. These are many ways for showing the distribution of temperature on the map with the help of isolines. Distribution of different factors like heights, that is contours, not only that temperature, that is isotherms, pressure, that is isobars, rainfall, which is measured with isobites, can be shown on regional or global level. Now, isolines are drawn by joining all the places with some values on the map. Now, in detail, we will learn about this in the next slide. Let us see. Now, here you have a map and some values are given over it. Can you see? Yes, it's 25, 20, 15, 10, 5, 0. Then in minus 5, minus 10, minus 15 in the northern and southern hemisphere. Okay? So these are nothing but the measurements which are written for joining the places in the northern and southern hemisphere of the earth. Now these lines are called as isolines. These all lines, you can see those pink lines, they are called as isolines. You can see the lines, it's somewhat in the oval shape, which is joining both the northern and southern hemisphere with the same value. Now look, see the number 25 over the southern hemisphere and northern hemisphere. Can you see 25? Only look at the number 25. It is the same isoline which is joining in both the hemisphere. You can see it's the same line which is joining in both the hemisphere, that is in the northern and southern hemisphere. Now let's see, consider the temperature of various places on the earth and the map of global distribution that is prepared. Now when you see this, isotherms are the lines that connect places with the same temperature after avoiding the effect of height. These lines generally appear parallel. See, it's almost in the similar direction to the latitudes. You can see some lines are parallels. Can you see? Some isotherms are parallels. This line occupies area close to the equator. See, it starts from this 25. It's starting somewhere from near to the equator. 25 is near to the equator. You can see, right? Yes, near to the equator. When it is passing to the southern hemisphere, again it is touching the equatorial latitude and it is passing again towards the northern hemisphere. So this line, that is the 25 line, is going in the northern as well as in the southern hemisphere. So this entire line that is passing from the equatorial region and moving towards the northern and southern hemisphere with the value of 25 is the isoline shown. Now the areas where the temperature changes rapidly, that is fast, the distance between isotherms is less. And vice versa. That means in the opposite areas, the temperature is again high. If I take of an example, see the numbers 15, 10 and 5. Look at the numbers 15, 10 and 5. The distance between these lines are too less. Can you see it? They are very less as compared to 20, 25. So the temperature differences are almost less. But when I compare this 25, 20 and all the temperature differences of these isotherms are more. That means 20, 25, you can see the distance is also more and the temperature also becomes more. Now observe the isotherms of 25 degrees Celsius in the map. Okay. This line occupies area close to the equator. Can you see 25 is close to the equator, both, that is southern and northern hemisphere. The shape of this line appears like an ellipse on the map. It appears like an ellipse, means circular, it is moving. Now, the north-south spread of the ellipse is greater on continents as compared to the ocean. The isotherm line occupies some parts of the continents. Now look at the 25 line of both the hemispheres. It occupies some parts of the continents. It's also going into the continents. You can see South America, Africa, Asia and Australia. It's passing through those continents. See, it's moving like this. Some part of this line is on all the 4 regions. It's in all the 4 regions. A very limited portion of the Pacific Ocean is also occupied. You can see the number 25. It is somewhat close to Pacific Ocean also. You will find that 2 isotherms with a label of 0 degree. Can you see after 5 there is 0 degree in both the hemispheres? Right now you have to look at 0 degree. So this 0 degree isotherm from the southern hemisphere is largely straight and is parallel to the line of latitude. Now look in the southern hemisphere, the 0 degree. It's parallel, right? You can see it's parallel to the latitude. It is moving upward, but If you look in the northern hemisphere of the same value, that is 0 degree Celsius, 0 degree in the northern hemisphere. Here it is parallel to the latitude. It is not parallel. It is moving upward and downward. Can you see 0 degree Celsius in the northern hemisphere? It is moving upward and downward. It is not at all parallel and it is deviating itself to north and south. So it's not parallel. It's moving upwards and downwards. Can you see the northern hemisphere's isolines? Yeah. Okay. So in the west parts of Pacific Ocean, it is fairly straight, but when it enters the continent of North America, it somewhat turns northwards. Then the line proceeds towards the eastwards, towards the Asian continent. Within a short distance after entering the Atlantic Ocean, it turns towards the northeast. Now, what does all this mean? What does all this mean? It means that now this is the method where you can understand how isotherms acts for the temperature changes in different regions of the earth, right? There are different temperature you can see in the southern hemisphere the iso lines are a bit closer, right? So the temperature is lower over there, and where it's far the temperature is higher. Now let us move forward towards the last topic of the lesson, that is thermometer. Now different types of thermometers are used for measuring the temperature of air. Mercury or alcohol is used in the thermometers. The freezing point of mercury is minus 39 degrees Celsius and the freezing point of alcohol is minus 130 degrees Celsius. So what is used in the thermometer? Mercury and alcohol. These materials are highly sensitive to temperature variations of the earth. Therefore, variation in temperatures from minus 30 degrees to plus 55 degrees can easily be observed with the help of these two materials, that is mercury and alcohol. Then the next point is the unit of measuring temperatures are degrees Celsius or degrees Fahrenheit. Okay, as shown in the figure over here, you can see in the figure. Okay, these are expressed as degree C. You can see degree C means degree Celsius and degree F, that means Fahrenheit. Okay, the differences in daily temperatures, that is maximum and minimum temperature, can be observed with the help of this thermometer. Air temperature is also measured in Celsius. So, alcohol is used in the thermometer to measure the temperature in the cold regions. So, what? Alcohol is used in the thermometer to measure the temperature in the cold regions. And mercury is used in the thermometer to measure the temperature in the hot regions. So, there are different types of thermometers used in different regions. Now let us have an activity. See the diagram and answer me the questions. What is the tube of the thermometer fixed on? The answer is the tube of the thermometer is fixed on a mount. Second question is, what substance is used in the thermometer? Just now as we seen, mercury or alcohol is used in the thermometer tube. Third question is, what do the figures on the scale indicate? The answer is the figure on the scale indicate temperature scale. And the fourth question is, what does the temperature in the figure indicate? The figure indicates summer season. Why? In the figure the temperature is high, right? So it indicates summer season. Let's move forward. Now students, let's have a quick recap of what we learned. We learned first, what is temperature? Temperature is a degree of hotness or coldness measured on a definite scale. We also looked at the distribution of temperature on the Earth's surface, which resulted in 3 different zones. First is the torrid zone, also known as the tropical. The second we looked at is the temperate zone, and the third zone is the frigid zone, which is known as the polar zone or polar region. Then we also saw the different factors influencing the distribution of temperature on the earth. The main factor is the parallels of latitudes, whereas the other factors are the nearness to the sea, continentality, the surface feature of the earth, the physical setup or the physical feature of a land. Then the next we looked at is the range of temperature, where we also understood what is the range of temperature. It is the difference of temperature in the coastal areas and the continental areas. So, coastal areas is the land close to the sea or ocean, and continental area is the land which is not surrounded by any water body, right? And the next we looked at is the greenhouse effect. We learned how the greenhouse gases are trapped in the Earth's atmosphere, which also affects the temperature of the Earth. That is it, heating the temperature of the Earth. And the last we learned about the thermometer, where different types of thermometers are used for measuring the temperature of air. Mercury or alcohol is used in the thermometers. Then the units of measuring temperature are degree Celsius or degree Fahrenheit. Then air temperature is measured in Celsius. So all this we learnt in this chapter. Let's move forward. That's your homework. The first question is, the difference in the maximum and minimum temperatures of a day is called dash. Next is, the gases due to which the temperature increases are called dash. Next question is, what are isotherms? And the last is, what is the annual range of temperature? That's all for now. We have completed the chapter over here. We will learn the next chapter in the next video. Thank you for listening, children. Goodbye. Take care.